All right, we're on to the next one, which is PMStore. We're looking at it for a new OSD backend. Lucas, give us an overview.
Yeah, we started developing a new experimental OSD backend basing on PMStore and open source PMM library, which is specifically designed for working with non-volatile memories. And our backend will be designed for non-spinning disk like SSDs, NVMEs, etc. And the main idea is to use PMStore code base, the same object handling and collections, but instead of allocating memory for the objects, we're storing it into the memory mapped file. This memory mapped file is divided into fixed size blocks to cope with fragmentation. We know we're losing we're losing part of the storage with it for the particular small files. And for this PMStore works with the library, which will be soon open source, which uses this libpmm library, and it's designed to handle blocks. Default block size is 1 megabyte for data, and for now we've got 8 kilo for exarch and OMAP related entries. What? Give me a sec for. Yeah, each object have a vector with block IDs. At read and write, we're just mapping the block number to the corresponding pointer in virtual memory, which is backed with this memory map file, and performing just simple mem copy on it to write it. Writes isn't so good right now, but as for read, we there's page cache is heavily utilized and allow us to use kernel page cache as some sort of last recently used file of blocks. So read performance for now it's quite good. Basic implementation is in place. We're in the process of also open sourcing it, and we will probably share it via GitHub. Simple Rados bench are passing. Also test with RBD. So we'll starting testing with virtual machines with QEMU and librd backend. As for tasks related, there's a few corner cases we're still finding with Ceph test object store utility, and we're working to fix it. And also what's left, it's more efficient key serialization, because for now it's simple. I forgot to add that the block we saving into the pool consists of initial metadata like key and value length, version of the object, and its checksum. The scheme is that when the block is updated, like from some offset to the with some length in the middle of the block, the whole contents of the block is copied, and later are the changes is moved. Basically, the whole backend for these objects for the PMStore, it's some sort of works like transactional user space block device, which utilize kernel page cache and allows direct reads and writes via virtual memory.
So what's the general strategy for laying things out in virtual memory? Do you have to do like garbage collection at this layer, or is that handled at lower levels?
As for Journaling, we write for each transaction in Ceph, we're writing a simple transaction log, which includes which blocks was written, which was deleted, and which blocks are updated. And the updated blocks, the old blocks from update operations, are released only after the transaction commit. And also, we've got recovery routines for the startup. And what's worth noting that the whole index of the objects and collections are kept in memory. We at startup we're just rebuilding it from each block metadata.
You do a full scan of the OSD store to rebuild the metadata tree?
Yes, but it's only at OSD start. Later on, it's kept in memory.
So for I don't know, how big will these devices be? 4 terabytes? Let's say 4 terabytes. For a 4 terabyte OSD drive filled to 60% capacity, how long would it take to do that scan?
Actually, I don't know.
Minutes or hours is what I'm looking for.
I didn't. I haven't tested it. I don't have 4 terabyte SSD drive right now. So,
I'm just curious as to whether you'd expect it to be seconds, minutes, or hours.
I believe rather minutes than hours.
So is that what you expect to do sort of when this becomes production ready, in a sense, or is this a temporary thing?
Sorry?
That is, are you?
You're asking about current state, or?
Well, I mean, is this the plan going forward, or do you plan to persistently write down the metadata at some point?
Metadata is kept in memory alongside and also are written for the each block on the persistent media.
Okay, and that's the plan. That's the design you're going for.
Yes.
Okay.
Yes, and written metadata is only used for this startup time. Later on, we're using in-memory structures.
Yeah.
And I believe, I don't know what I could tell more about it. It could be more clarified when we finally open sourced it, and you could grab the code and test it. Like I said, for now we're testing it that our OSDs are max size, I remember, as I recall correctly, it's 4 gigs setups for OSDs.
Yeah, you also mentioned possibly optimizing things for like zero copy in the future. Maybe you started looking into that very much.
Yes, because like I said, we keep in only the block number in the vector in the object. So possibly it could be possible, and also it is very simple to translate this block number to the corresponding virtual memory address. So it could be possible to just make a new buffer row class which takes these blocks, marks it as reserved, that it couldn't be that it couldn't be deleted or cleared after the update operation, and pass this buffer, and when there will be read by the endpoint of when the message will be constructed, it will be possible to just copy from the virtual memory address from the file instead of taking space from memory allocator pool.
Great. That's exactly the approach that that sounds good.
All right. Any more questions related?
Are there any like peculiarities about the backend? Like what's typical block size for it? And when you're like updating portions, you mentioned that you have to rewrite the entire chunk.
Yes. For now, unfortunately, yes. And to avoid losing space from the OSD for extended metadata that we're using for now 1 megabyte blocks, we're working to improve the backend to just small writes to the to the half of the block to store it into the transaction log, and then at execute when they're all journal is persisted, we just update it in place. But also it will be complicated the zero read path, so it's still under the development.
Okay.
But one thing that this block size is configurable. So we're using for now 1 megabyte block, but it could be just lower. Like I don't know, 512K, something like that.
Do you have any other like ideas for the design of this that you didn't go with? And can you explain like why you picked this one?
The whole design phase started with trying to utilize this library from non-volatile memory. So our first choice, first of all, we've tried with KeyValueDB, but after a talk with Sage, it appeared that it's not heavily developed. So he advised us to use just general object store interface for use it. And later on that we will trying to optimize it for persistent memory. So PMStore was obvious choice for it. Also, I need to investigate better the whole PMStore, and maybe there's some sort of optimization there, possibly to be done, because well, from what I saw, that's just only to validate the object store and quickly test. The Ceph.
Yeah, it was never really.
I'm concerned about locking scheme. I'm still thinking about it.
Question. So the object store interface currently requires some kind of a callback based write interface, right? When you do a submit transaction, you give it a context to be called on applied and on complete. For you, I would imagine that that's excessively heavyweight. You probably have a finisher thread whose only purpose is to call those contexts. Is that true?
Actually, no. We don't have operation sequencer. We're doing it synchronously. So when there's like I don't know if you know the PMStore, how it works, right? It just takes a transaction and process operation by operation.
Yeah, and then shortly thereafter, it takes the context that was passed in and sticks it on a finisher to be called. It wouldn't be able to call it from the same thread context because usually they take locks. It's a dumb reason, but that's the way it is. Would it be interesting to you if the object store class supported a polling-based asynchronous write?
And
similarly with, so that rather than you needing to schedule a callback, you would fill in a small object with enough state that the object store client can check to see whether the write has been completed. this would allow us to serve the entire write from a single op thread pool thread without needing to do the write completion component from a different thread. It might buy us some locality in the case of extremely low latency backends like the one you're building. So I wondering if you had any thoughts on that. Not like immediately, but I've been thinking about that lately and changes to the read path. I assume you're perfectly happy with having a synchronous read, right?
Yeah, for now it looks like it's sufficient.
I was thinking that each op thread pool thread could have a vector of in-progress operations, and every time it finishes one, it goes and checks whether the other ones are ready to make more progress, either because the backend has completed a write or because the messages come in. And that might buy us some locality. So if you guys have any thoughts on that, that would be an interesting conversation.
I should follow up with you about this on the mailing list because it sounds interesting.
Yeah, we never had a backend fast enough to where the object store interface is elegant in some sense. It's nice and contained, gives you transactionality, but it's clunky, and the context thing is very heavy. So we might do something like extend the object store interface so that the implementer implements either the synchronous version or the asynchronous version, and whichever one you don't implement is emulated, which might be an option. And then generalize the OSD code so that it can deal with either.
Wrapped up on this one, or are we still thinking?
No, I'm waiting if there are any more questions. I'm glad to answer it, but I believe it's all for me.
All right.
Like I said, I believe if we could have some more productive discussion when the code will be published, and we will have the occasion to grab it, look into it, and I believe that we could discuss it a bit in detail. Okay, thank you all.
Cool. Thanks, Lucas.